All right. Okay, so the first thing to note is that the actual change in V, right? We're going to estimate change in V, but the actual change in V is this area, is whatever the number or the amount, whatever the amount of space is in this area. This is change in V. Okay, this amount of space, however much it is, that's the actual answer. That is the actual answer, change in V. But we're going to estimate it. We're going to estimate it. We're going to estimate using three rectangles, each having width 1, 0, or 1.0, sorry, 1.0, and left-hand endpoints. Okay, so we're estimating this area, so the 2, 5, right, that refers to this interval, 2, 5, from 2 to 5. And so this example isn't too difficult. The widths are 1.0. So starting at 2, going over 1.0, right, that's that distance there. So this is a width, one of our widths of rectangle is going to be here, another width here, another width here. So we have 3 rectangles. Okay, now to decide how far we go up for each of our rectangles, we use the left-hand endpoint. We use the function value v prime of 2 to decide how far to go up. Okay, so I'm going to draw my rectangles in purple. All right, so first I'm just drawing this rectangle right here. The first rectangle, my first approximating rectangle. And now how high do I go up? I go up v prime, I go up v prime of 2. So v prime of 2 is there. You can see v prime of 2 determines my height. Okay, so there's my first rectangle. Now my second rectangle, the width goes from 3 to 4. Now remember, I'm using left-hand endpoints to determine my heights. So v prime of 3 tells me how far to go up to there. Looks like I'm going to run out of room here, aren't I? All right, I think we know what it says there, so I'll get rid of that. Okay, so let's get straight up there. Okay, and now my third rectangle, this is my width of 1. 5 minus 4 is 1. Okay, and now you see that once I find the area of each of these rectangles and add it together, that's going to be my estimate for the change in V. So change in V is approximately area, let's see, rectangle 1 plus my area, rectangle 2 plus area, rectangle 3. Let's say this is rectangle 1, rectangle 2, rectangle 3. Okay, so the area of rectangle 1, let's see, what's that? Area of rectangle 1, let's see, my width is 1. So we'll say length times width. Now let's see, what is my length? My length is v prime of 2. V prime of 2 is 4. 4 times 1 there, okay? The area of rectangle 2 is a 1 for my width. What's my length? V prime of 3. Okay, that looks like it's about 3.75. Times 1. And now rectangle 3, my width again is 1. And my height is V prime of 4, 2.75. Okay, so you can see that 4 plus 3.75 plus 2.75, do the math there. Let's see, what would that be, right? Let's see, you've got 4, 5, 6, 7, 8, 9. 9 plus 1.5 be 10.5. So my change in V, approximate, using 3 rectangles where heights are determined by left-hand endpoints, is that. And you can see by way of this graph that this is an overestimate, right? It's an overestimate. How much should we overestimate by? We overestimated by exactly that much.